Good evening all. Myself Dr.A.Vaniprabha, Associate Professor, EC Department, SNS College of Engineering. In following with the last lecture series, Merkle Tree and Patricia Tree, today we are going to discuss about Merkle Patricia Tree. As Ethereum is a developer and programmable blockchain, the data structure that is followed so as to store the information or transaction is Merkle Patricia Tree. It is a blended form of Merkle Tree and Patricia Tree. This Merkle Patricia Tree is used for representing certain data in the header of an Ethereum block. Merkle Tree has important role in the management of blockchain network as it uses the hash representation to save storage space and speed up search operations. Patricia tree is a tree-like data structure used to store key-value pairs. The compression technique in the Patricia tree reduces the storage requirement in the blockchain. In Ethereum, each node of the tree is referenced by its hash value, like a Merkle tree. The root hash acts as a digital fingerprint of the entire data set represented by it. If any key value is updated, the Merkle root will also change. Ethereum keys are represented in a hexadecimal format which has 16 possible characters right from 0 to 9 and 8 through F. Merkle Patricia tree comprises 4 types of nodes, namely null, branch, leaf and extension. Null node is a non-existent node represented as an empty string. Branch, a node that links to a maximum of 16 distinct child nodes corresponding to 16 hex characters. It has also a value field. Leaf node, an end node that contains the final part of the key and a value. Extension, a shortcut node that stores a part of the key based on a common prefix and a link to the next node. The link fields in a node stores the hash value of the next node. This hash value is used as a key to retrieve the actual node from the database during traversal. Therefore, searching a key in the tree requires multiple database lookups for getting the nodes in the path. Leaf nodes and extension nodes have similar like structure. A flag is included at the beginning of the path value to differentiate between them. There are 3 tree structures in Ethereum. They are state root, transaction root and receipts root. So this is the pictorial representation of state root, transaction root and receipt root. And here, this is an example for Merkle Patricia tree. Right? So the nodes are named as 0, 1, 2, 3 up to 9 and A to F. So every base, this is the table which represents the transaction details in the particular account. So we are going to represent these details in the form of Merkle Patricia tree. So let us start from root node. Root node and next is branch node, leaf node and extension node. So in the root node stores the first 2 values of the account field. So first 2 value is D4. So the remaining values are the branch information. So the key value is nothing but D4 and the next is the information 318. So this stands for branch node and it represents 8 value, whereas 1 is the leaf node connection and here the key is nothing but 18 for 50 ethers. Right? This is from 3 and this is 18. And similarly, here from the branch node, you can identify the value 7. 7 leads to a leaf node and whose key value is 85B and the transaction detail is 30 ETH. And similarly, from A, it reaches the key value OC, which is nothing but ethers. So the root of Merkle Patricia tree does not depend on the order of the data. However, Merkle root depends on the order of data. Tree size of Merkle Patricia is lower than a standard Merkle tree due to prefix-based compression techniques. Merkle Patricia tree are faster than Merkle trees, but implementation is complicated. So these are the main differences between Merkle tree versus Merkle Patricia tree. As a nutshell, Merkle Patricia tree offers quick search and reduced storage. Hope you all have understood Merkle Patricia tree. Thank you.